Hello. Today in this video, we're gonna pit two models one against the other to see how they perform. One model is Sonnet 3.5 that you can use in Claude or in WebSim. Another model is a new OpenAI o1 model. And the way we're gonna do it is by asking them to write a car parking simulator with physics. And this is something that Sonnet 3.5 repeatedly failed to do for me before. So it's gonna be interesting. Why this is going to be interesting? Well, O1 is a new OpenAI reasoning model. It's actually two models. In ChatGPT, you will see O1 Preview, which is larger, slower, more expensive, better model. And there is O1 Mini, which is faster, smaller, cheaper. You will only get 30 calls to O1 Preview per week and 50 calls to O1 Mini per week. So kind of limited for now. Now, what does it mean that it's a reasoning model? Well, one example OpenAI gives in their blog is this number. Their previous best model, GPT-4o, could only solve 13% of mathematical problems correctly in International Mathematics Olympiad, while O1 can score 83. This is 6x improvement. Not 100x improvement, it's still 600% improvement. So not as high as hype, but pretty high and very, very impressive. How does it do it? Well, it was specifically trained to think for longer, uncensored, in a way that OpenAI hides. So it thinks, but you do not see it. Then it summarizes and censors its thinking, shows it to you, and proceeds to solve your problem and answer your questions. This together allowed it this kind of 6x improvement, which is, again, very impressive. But I wanted to test it for myself. How can I, myself, feel this improvement? And what is the easiest way to do this? To answer like, is it better? The easiest way is by comparison. So I want to compare it today to a previous best model I know of, which is Sonnet 3.5 from Antropic in Claude and WebSim. Now, however good the model is, however impressive it is, it did very impressive things for me before, surprised me. I asked it once to write for me educational game of how to park. Top-down game with physics, with rotating wheels, with acceleration, with brakes, and with trails for car wheels to show where everything is when you drive. Kind of a visualization for you to learn how to park correctly. And this is what I asked it before. I asked it to write this kind of game. And it was failing time and time and time again. Well, today we will try and see what O1 can do for this problem. So this is a fight, and this is round one. Let's go. Okay, so here is a chat I had with Claude. I copy-pasted my prompt, it lost the formatting. I'm asking here for HTML, CSS, and JavaScript game in GTA top-down style. It should be parking game. Car should have 4 wheels. They should rotate. There should be realistic physics and friction. And it should be parking game that leaves trails behind it wheels, like trails of wheels. Okay. Not super prompt. There's just something I wrote quickly. Here is what Claude understood and tried to do. So it said, yes, I will create for you this kind of HTML, CSS, JavaScript game with rotating wheels, realistic physics, and wheel trails. And writes like everything else. I can see that it understood correctly what I wanted, and it wrote this. A gray square. Nothing happens. You cannot write, nothing happens. No errors, nothing. So it fails. Claude failed from one shot. We can take a look at code. As far as code goes, it didn't use any kind of third-party libraries. There is some CSS and there is JavaScript. It uses Canvas. It wrote all on its own. It's just not working. Considering there were not even errors, it's even hard to say what's wrong. Okay, next, let's see what happened in WebSim. It uses the same model. We can see that I have here the same prompt, just formatted here with lines. And from first try, it also failed. It showed an error. And when I've tried to fix the error, it did this. Exactly like I wanted, right? I did ask it to change some things and got this. Now at least it doesn't fall down. Partially problem is that I asked it for physics game and it used physics engine made not for top-down games but for side-scroller games. But we can also here see why this prompt is problematic. It includes using physics engines, a third-party dependency. And physics engines are notoriously very flaky in a sense that even small mistakes in how physics works makes them go crazy. That's what you see here. So asking a model to write this kind of code, it needs to write the code. It needs to understand how to use library, and it needs to understand what I asked in context, that I want a top-down parking game. How do you use a physics engine correctly to make it work and also render correctly? This is it's not easy because we are asking a textual model. It never seen things. How can it reason about physics and how to use physics engine for it to correctly simulate what I am asking? This is hard. Even with iteration, with Sonnet 3 in WebSim or in Claude, this thing fails for me. I've tried multiple times before. I wanted to make this to help my wife illustrate how parking works, when and how you should reason about where your car is and how different parts trajectories go when you're parking, and I couldn't do it. And I don't have time to sit down and do it on my own. It could take days. It's not actually easy to do this from scratch to work correctly. So Sonnet and Claude and WebSim fail for me with this kind of prompt. Let's take a look at what OpenAI wanted. Here is the same prompt. Here is chat with ChatGPT o1 preview, the slower, more expensive, smarter model. It thought for 24 seconds. It didn't show whole reasoning, it just showed summary of it. And we here see that it says crafting the simulation. I'm creating GTA 2 style top-down car game. It will be HTML and JavaScript. It will design on canvas. There will be controls. Mapping out the game. I'm setting up HTML. The game canvas will serve as rendering area. Setting up environment. I'm pulling together the game canvas, driving car class, focusing on speed, acceleration, steering, position updates, and rendering. We can see that it's reasoning through in different ways through what it's going to be doing. Then it should have enhancing car physics. I'm working through realistic car physics, including wheel rotation. It's like self-talk, like it's self-affirmation, what humans do, in the sense that, what is it that I'm doing now? Oh, yeah, that's what I'm doing. Okay, let's do it. So interesting. What's interesting that Claude also does that. We can see here some of its reasoning being put out, but there is also a hidden part of the reasoning that they do not show. We know from prompts that they have thinking parts and they are not showing them here. They're hiding them. So Claude does this too. And this does this too. Does it perform better? Well, it generated this kind of code. Actually, big one. Usually ChatGPT was not generating such a big one code. From what I've seen, O1 preview and O1 mini can output very large answers, something like 8 or more, like 8 to 16 times larger than before. This is not 8 to 16 times larger than before, but it's in a large answer. And we can say that it gives us explanation. Like there is HTML, canvas is of this size, there are colors, there's car code. It explains everything about the code. You can read it and learn on some level of what the code it wrote does. It has features, realistic physics, how to use, used with these arrows, and we have code. What we can do is we can copy that code. We can go to CodePen, paste that code. Let's save so that we have empty one. Save again. And this is what we got. It's a little bit unfinished, but it's working. Wheels rotate. I can go back, I can go forward, and it is drawing a line. Only issue is that this line seems to be the middle of the rectangle of the car. It's a little bit not what I want. I probably would draw actually trails of corners of the car's body. I think this is the most important thing for this kind of game. But it did it. It did it from first try, single prompt, one shot, no correction. It just works. This is impressive. So that's it. I just compared Sonnet to O1 model. O1 did in one shot something I was trying to achieve with WebSim or Claude. It's not perfect. Then one more interesting thing happened. I gave this code to WebSim to see what it's gonna do. Let's take a look at that. So I think it was here. Here I gave WebSim the same code. and it worked. We have the same car that O1 generated, but WebSim added other things. We can see speedometer. We can see parking spots. We can see score. We can see buildings, and if we go into the building, it's gonna become red. We can go and try to park. Oh, we got 100 score and 4 parking spots remaining. We can go to the next one. I also wanted a little bit more work around the trails. Now we have 4 trails. And we have also some settings. So we can change acceleration and some other things. Now it rides faster. Wee, 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 wee. Oh my God. So what happened here, and we can go and see the prompts. So we can see that first prompt was just code that O1 generated. And then I said that make it draw 4 trails, 1 for each wheel. Leave other things as is. Add settings control, minimal and maximal speed, friction control, and so on. Make left-right arrows, rotate the wheel, and so on and so on. So I iterated with it a bit, and I got even better version. So what's happening here is I gave result of smarter model, presumably. Seems like O1 is smarter than Sonnet 3.5. I gave thinking from smarter model to a less capable model, and it was capable of using it correctly, not breaking it, and improving upon it, which is interesting and impressive use case. You can use smarter models to get you started or for hard problems, and for other things, use cheaper, faster models. It's an interesting future we're going into. So this is another thing I wanted to show. Now, all of what I've showed you, I've did yesterday evening. Now I want to do a little bit of live testing with you, the GPT-4 model. And here I want to create, so we are using preview. I want a new chat. So what I'm thinking, I still slightly dislike this. I think it's not realistic enough in some ways. It doesn't really behave like a physical car. And it got me thinking. While O1 is impressive, it moves the button further, it can do more. It's not that sky is the limit. Ceiling has risen, but it's lower than the sky. And this is what I want to show you because I was playing with it a little bit and it does fail. It does more complex things and fails less. It still fails. So what I was thinking, let's ask it to make a 3D game. Let's make it even harder. Let's try to push it until it breaks a little bit. Let's make a harder game. I want HTML, JavaScript, and CSS game. It should be in 3D with physics. It should be parking game. There is a car, 4 wheels, front wheels rotate, wheels are round. There is friction, inertia, and everything else to make it realistic. Purpose of the game is to allow people to learn how to park, how to think and reason about when and why and how you need to rotate the wheel. What are trails and trajectories of wheels and car corners? So people can learn in the game and apply that knowledge to real parking. Let's ask it this. What's interesting here, and I do suspect it's going to fail, what's interesting here is that I'm now asking it to use third-party library game engine, and it's in 3D, and it should be realistic, and there is purpose in teaching people how to park. So let's see what it's going to do. It's very challenging ask in some ways. So it's thinking. It's crafting. So crafting parking game, 3D, in HTML, JavaScript, CSS, setting up 3D elements, crafting a game, creating a realistic 3D parking HTML game. It will use 3JS library and Canon.js for physics, Note, due to the complexity of full-fledged game, the following code provides a basic framework. You can expand upon it to add more features. Okay. Okay. So what I dislike so far is that it writes it as a bunch of different segments. I want to ask it, can you write it as one large HTML code block? I can copy and paste at once. So on the reasoning side, I think it's a good choice. 3JS is most popular library. Canon.js, I do not know. I have not much experience with 3D physics. But it seems more or less correct. It creates the car, there is geometry, there are wheels, and there is a lot of opportunity for failure. It is a very hard task. So now I asked it to do a one block. It thought for 7 seconds and wrote for me a block that actually looks smaller. Is it? We can see it's probably not as good. Let's create a new pen, see what this small block did. Okay, it's actually the only thing it's not writing. Can I? But it's almost there. Okay. I wonder if we could add all of that. Let's try to check. If we search for this, it is here twice. Okay. Okay, let's give it feedback. Let's see if it can iterate. Oh, I see that wheels are in different directions. It cannot analyze images as well, so it's not multimodal model just yet. I didn't check in. Maybe it is multimodal data, just didn't expose the capability. Oh, what's interesting in hand, it's still continuing to work. It didn't finish. So let's give it feedback. It seems like wheels are not correctly positioned. They go parallel to the ground. So when I press arrows, car does ride anywhere. Can you ruminate on why and how to fix? So I don't want to make this video too long. After this iteration, we're gonna stop. For this last part, I just wanted to demonstrate that it's not magic. It is better. In some ways, it's considerably better, but it's not human level developer yet. On the other hand, it's fast. It is faster than human developer doing this kind of things. So it's again, noticing issue, the user has pinpointed the wheels as parallel to the ground, causing the car to stay motionless when arrows are pressed. Hang out the options, analyzing code setup, ensuring correct wheel setup, navigating orientation differences. Oh, it's thinking. It was thinking for a while and it failed. So yeah, no magic there. Let's see. Okay, this time it thought slightly less. And it's writing new code. Well, let's keep our fingers crossed. Maybe it's gonna work. As you can see, it writes more code. I wonder how many lines that is. I remember they were speaking about something like 32,000, 16,000, 64,000 tokens. This is a lot. It wrote a big one that explains what it tried to fix. It even wants to run. Oh boy, this is going to be interesting in agentic workflows. It speaks about how to test that you will need run to server, open it. I wonder if it's going to be able to manipulate a browser eventually. Okay, so we here have new code. Let's give it a try. See? And I think it completely failed. And it failed. So, not magic. It's better and impressive, but still will require iteration. There will be types of problems for which it's going to be failing. This is all I wanted to show today. It's better. It's going to be interesting to see where it goes. This was round one. In it, it did win against Sonnet 3.5. I will be playing with it more during the next weeks, and I will make another video if I learn anything interesting. So if you like this kind of things, push subscribe down there and see you next time.